Yeah, would not recommend naming anything that unless it's a room of snow professionals, because then that joke doesn't land very well. Also, yet another PowerPoint that isn't my thesis. But yeah, I just kind of want to talk about sort of the intersection between forecasting and being a practitioner and all of these research methods that are coming around, and then ties to being in a mountain community generally that relies on snow for like economy, for water, all these things. So this is pretty cool. This is a NIR image, so it's near infrared. It's not a photo. It's on a tree and it's a time-lapse camera, and that's Heaven's Peak up in Glacier where I work in the spring. So that image was made with near infrared. And it's a passive sensor, so it just measures sunlight that's reflecting off things. So that's kind of the sunrise in the morning reflecting off Heaven's Peak. A little BTAC update. So this, wait, I can't mouse. Here's where Alex and I forecast now, which is pretty wild. The Tetons are as good as they say. We're skiing. Yeah. Fortunately, this whole zone that's massive is very similar to Southwest Montana and snowpack, so that's been nice. Feel closer to home that way. But pretty interesting to be part of a foundational change for this avalanche center. New director, all new forecasters but one. Change to the National Avalanche Center forecasting platform. So a ton of change at once for a community that has not seen a lot of change in a long time. Really great skiing. And really interesting snowpack year. I think I won the award for most remoted avalanches this season, which I think means I'm doing a good job because I can find instability. Close in that photo are like Alex and my track down the center of that, and then two big remoted avalanches on both sides. But yeah, really interesting snowpack year down there with early season snowfall and the low elevations that hung out. And we've been getting these pretty interesting avalanche cycles that are YDOT's problem and not ours. But this one was triggered by an elk across the road. And this is the infamous, if you've heard of it, Taco Bell couloir. That is a path that fills in behind the Taco Bell, now TJ Maxx in Jackson. And some kids, you have to poach this because to get onto it, it's private land. We're dropped off at the top and triggered an avalanche on it. And it was interesting to go up this ground. Go ahead. And then that's just Nick Armitage up there. Figured this is a good community. We went to go check out. There were a lot of accidents. Luckily, not a lot of fatalities, but we got to go check out a lot of interesting crowns this season. So, onward to the talk. I'd like to thank HP Marshall, Eric Peich, and Zach Miller. Those are kind of the integral people tied to all this research that I'm going to talk about. So mostly I want to review the importance of snow as a reservoir for water in the West. I'm going to talk about SnowEx, which is a campaign I worked on for 2 years and am continuing to work for through Boise State University. It's funded by NASA primarily. And then the NORROC is the USGS work up in Glacier. And then kind of highlight all of these relationships that are happening that are really complex between, community, forecast center, snow research. So monitoring snow is really complex and really challenging, right? You usually, have a lot of point data, and that gives us a certain amount of representation of the mountains, right? But often, things like this are happening. Like this was, we got 41 inches of snow in 48 hours, and then it is blowing away in this picture, essentially just sublimating into the air, which happens in the mountains, right? But not necessarily at your SNOTEL site. So understanding all of these complex dynamics is something that we're all, or at least as researchers, as ski patrollers, right? As forecasters, we're all trying to get a grasp on this at some level. And from 1960 to 2005, 53% of the runoff for the US originates in snowmelt. And that was a paper published in 2017, so it's probably more. And if you live in a community that relies on snow, that's even higher. It's like 78%. So it's kind of fundamental in our water cycles and in like cycles moving through even fire seasons. So we see a lot of these, right? Which looks really good. But underneath this image is the fact that these numbers are less reliable, and that snowpack is less reliable as a resource over time. Because what matters is how this ablates, right? If it all ablates off at once, that 130% doesn't matter, because there's no way to store it. And through time, soil is also getting drier, and so it'll absorb a lot of the runoff right away, and it will never reach the river in the first place. So these things are continuing to happen. This is really good for skiing right now, though. But the reliability is, again, decreasing over time, which is a problem. These averages are also reimagined every 30 years. So if you compare these snowpacks to snowpacks before 30 years ago, they're far lower still. So I'll talk a little bit about SnowEx, which is one of the campaigns that's really large scale, and they just try to throw all these tools at this problem. They use drones, we use LiDAR, we use air-based radar, we use ground-based radar, and we take a bunch of field measurements at once. And that's the really important part, right? Because you're validating all this instrumentation out in the field in mountainous snowpack as you're trying to use all this technology with it. So for the 2021 time series that I participated in, it was focused on dry, like intermountain snowpacks. And I was over in Idaho and in the Sawtooth portion of that, working as sort of the strong back of the monitoring of the snow. The primary instrument we used that year was interferometric synthetic aperture radar, which is just a type of radar that they want to put on a satellite and be able to launch into space and essentially measure bulk SWE. And radar kind of works kind of like submarine sonar. Like it sends out a signal and then it gets a signal back, and it's able to kind of infer what's there based on the signal back, if that makes sense. So it's measuring a change, so change in depth. And from that change in depth, you're inferring like a bulk amount of water in that mountain range. So this unmanned little guy would take off in LA and fly these big swaths over Idaho, Montana, and Colorado. And then at the same time, all of us little field grunts would be on the ground measuring all these properties to do the snow, because they don't necessarily know why snow has a radar signal. They don't know if it's the crystal type, if it's a density thing, if it's a temperature. So we're measuring everything while we're out there, but it has a signal. So that's kind of what an early season field site would look like. At the same time, also using a ton of other technologies like a snow micropenetrometer, a bunch of other ground-based radar things, and LiDAR in some cases. And then you saw this photo earlier, doing lots of density measurements, doing crystal structure of everything, taking temperature of everything. And then this is happening weekly or bi-weekly. So I was going out and doing this, and those flyovers were happening pretty consecutively to create a time series of that snowpack. And this is important because even though these projects are really like hydrology focused, avalanche centers can benefit from them and can help contribute data to help validate that equipment. The end result is you kind of get these are the radar swaths, and you can kind of see where differences in the signal that it's reading. This is kind of a flat image. This one's a little easier to see. So here's the swath. These are trees. So it's reading all these differences in the snow. And then these are all field measurements being taken, which is really good, right? You're like throwing this piece of equipment at snow that kind of works in this way that we don't fundamentally understand and we can't really utilize broadly yet. And you're also applying all of these field methods with it because that's necessary. Like, you need to be able to validate that equipment. Randomly, now we're going to go to Glacier. Talk about the forecasting side of this. It's a really unique spot to forecast. It's hard to emphasize like what it's like to forecast up there. There's like 40 avalanche paths across this road. And like, you know, the start zones of these are at 9,000 feet. And these avalanches, you know, commonly be D3 in the spring, travel 5,000 feet. So really large. This is me spotting plowing this road here. Not a lot of safe zones. But really beautiful, really interesting problems to deal with because there are grizzly bears everywhere. And really unique forecasting because no one likes being out in wet snow. Most people are out of ski boots, and we're in snow in that transition point beyond wet to dry or dry to wet, right? We're in fully wetted snowpack, watching it evolve throughout the spring, watching it melt off, watching as different avalanche problems happen with it in it every day. That was a bear den, randomly, that we would be skiing over. And then one day it was just open. And this is kind of what those paths look like.
I looks like it might be kind of tricky to cross.
Yeah. So this was last spring. And then this was the spring prior. And this is a wet loose avalanche, which we typically would not think of as scary, but they're definitely scary there. Bikers were trapped uphill of that wet avalanche. So this is kind of like what those problems look like, pretty significant. So it's pretty cool because as a forecasting operation, we utilize a ton of technology. There's a lot of weather instrumentation up there, and there's a lot of validation for us as forecasters, right? We write a forecast, we go out in that same terrain every day, and we see what happens. And it's, you know, such a tight zone that we're forecasting for that you can kind of dial in what's happening with the snowpack pretty well, even though it's really complicated because it's wet snow. So this is kind of, I can't see my mouse there. There we go. The bend of the road is here, and all this weather instrumentation is super useful. We get to use all of that. The garden wall is the most useful one. It's at 7,400 feet, which seems pretty low to us, but the top of those paths are, you know, you're starting at like 3,000 feet valley floor. That's what it looked like in late May of last year, as we all got that giant snowfall cycle. We use tools particularly aimed at these glide cracks. So this is one camera we mounted across the way above a glide crack haystack. And this was during the day. On a day, we were like, you know, Zach Miller and I had a conversation that evening of whether or not we should cross this the next day because other glide pockets were going, and there was concern that this one might, and it might, you know, it's very hard to tell if there's enough volume of snow there that it's going to hit the road because sometimes it does, sometimes it doesn't. And then that night at 10 p.m., this went. And at the same time, we're also looking at pixel deformation of it, which is useful. Looking at how that glide crack is changing over time. Jamie came up onto the road as well and scanned a bunch of our glide cracks with LiDAR, which was cool because we all got to place bets on how deep they were. And this one's 13 meters, which is pretty wild. But really useful, right? You get to throw all these tools, and it's a wet snow. And what all of these tools usually struggle with is wet snow. LiDAR, radar, everything has a problem once snow gets wet. So it's cool to be able to try to tweak it and use it with this. And again, lots of direct feedback with using those and with our forecasts. So continuing stuff we're going to work on up there is exploring that diurnal cycle. Doing stability tests on wet snows really frustrating, interesting, but doing like PSTs on wetted layers if there's a wet slob set up. And then, yeah, just kind of continuing to utilize those tools and maybe, making a tie with HP and getting some of the tools we've used with SnowEx used up on the road for forecast season. And then what about just as like general mountain recreators? Like, what can we do? What role do we play? We dig a lot in the snow, which is super useful. And useful because the Avalanche Center is like a hub of information, right? It collects all this data, which is really useful, and it's cataloged in things like SnowPilot, right? So it's really easy to pull. This is from our On Each Mountain forecast. We write a weather forecast. And then simple things like noting average depth in one zone over time is really useful, not only as a forecaster, but also as a researcher, right? Just looking at changes in depth. And then things like community snow obs, which if you haven't used is useful. I can log on to here and it pulls data from Mountain Hub, SnowScope, and SnowPilot. So even if someone isn't sending me their obs, I will find it somehow. Super useful, particularly in this massive zone, the gray zone that we forecast for. Like the Tetons are some magic little, I don't quite understand what happens there. A snow fairy exists because like this season, a small weak layer would form and then it would get buried with 4 feet of snow. No longer be a problem, which did not happen further south. We had like a few weeks ago, an HS of like 80 centimeters down there. Like, oh, not great, but would be great to know if someone saw that, right? I could see it on this. It's really easy to see that sort of spatial variability in that zone when you plot a bunch of points like this. So, I don't know, broadly, biggest gaps I see are kind of applicable tools from research being applied actively. I think that needs to be a tie that we maintain as forecasters and as researchers. I think more weird snow things are going to happen, like weirder storms, weirder weather patterns are going to produce weirder avalanches in weirder places. And I think that's going to be a theme that continues forward. So looking at that, and then also looking at those evolution of that snowpack over time, like how that structure stacks up certainly affects how it ablates in the spring. And so kind of being able to monitor that and maybe feed it forward for research. And then also just the fact that like regardless of whether we ski or whatever else, like this will affect us. And it will probably affect people downstream of us first in areas like California, Nevada, like areas that are already pressed for water. Where are they going to go? When that resource is tapped there, they will move here, right? And we'll have to, there are just large scale implications with snow and water and community planning and how all this is going to work. And then in addition to that, like how are we going to forecast for avalanches? Which seems really overwhelming and existential. But I think if, there's incremental sort of work in that direction, it's good. And yeah, community support of research in avalanche centers, like Kevin said, money for snow research, I think is really important, and people kind of acknowledging, the more people in a community like Jackson that actually know that, oh, snow is my water reservoir, and I maybe need to contribute to that. A lot of people just don't know how large of a contribution that is and how fundamental it is to the way they want to live. That's it. Nobody, okay.
Wow, that's a good talk.
Is that a good talk? Nothing, there are bears. I forecast a double bear spray. There's got to be some questions about that.
Gabrielle, do you have any ideas from this morning that you would like to apply to Glacier as far as messing up the name, but the full spectrum photography and the other tools that we heard of? Does any of that seem like you could implement that in the Glacier program?
Definitely. Like I already asked Kevin, I was like, I'll put that in the glide crack for you. Don't ask Peich. It's gonna be me and Miller that are up there like trying to, fish something into a glide crack. But definitely using that stuff. I thought of infrasound, like putting infrasound arrays up there as well. But it is this really cool little, section of a mountain where you're like, yeah, let's just throw a gambit of things at this, and it's a wild snowpack, right? Which is pretty fundamental to research. Like that snowpack has to be wild, which is hard, right? But it's changing dynamically as it would naturally. And if you're studying at the same time, especially with like temporally, you're getting a good time series of that stuff. Like I think that really pushes that research forward.
Then I saw the GeoPrevent. Is that, do you have radar from them, or is it just web imaging related to that?
Yeah, it's all just pixel deformation, and this takes a photo every 15 minutes.
And that's based on the system that Ron came up with initially?
I think so. Mm-hmm. Yep. But pretty interesting, timing of water is like a lot of the talks have been about water moving through snow and and it's really fascinating timing. Like you go drive up this road and there'll just be, the first 2 hot days and water will just be pumping down the road, like tons of water. And you're like, wait, okay, like things are gonna go. And then it'll cool off, be cold for 2 days or 3 days, and then everything avalanches. And so trying to wrap your head around like how much time that water takes to like permeate through the snow to maybe hit, in the case of the glide cracks, like hit the ground. And then, yeah, a lot of interesting physics at play, right? But they're all avalanches happen by physical parameters, right? It's just more like how hard they are for us to measure.
Are you doing more like crack analysis based on opening rates based on the pixel deformation versus water flow, would you say?
Mm-hmm. Definitely, yeah. And the two things we look at, the pixel deformation is huge. Like they'll definitely deform until they hit a certain point, but also a lot of it's just solar. Like this snowpack can handle so much rain. It'll just like torrentially rain, and it's just so locked up that you would think that would cause more avalanching, and a lot of the time you'll just sit and watch it take all this rain, and it's sun. Usually that causes a ton of instability here, but hopefully this season, it looks like last season there was no wet slab set up because they had a big warm up in March and everything essentially concrete when I went there, which is great. When Eric Peich is like, I want a full depth pit at the garden wall, and you're like, great, cool, 2 meters of cement to dig through. But this season they shut the park at Apgar Village. No one's been interior park. Usually skiers can access it, and I think that setup might be there, so it'll be interesting to see what happens this year.
Why do you think that the rain's not triggering stuff that then the sun triggers?
I mean, I think it's more, last year's snowpack was just so permeated with water already, had like perk column rebar through it, that it was just able to channel through really well. And the sun, it just starts to shed, and then once you heat up that top snowpack and it's able to entrain enough, like that volume will just start moving on the surface. So I think that's more why that, but it's really complicated forecasting. Like that weather station, like a lot of it's sky covered too, right? Especially with, whether something's refreezing or not at night, because that weather station at 7,000 would say, 23 degrees, and I'd be like, great, let's go up. Everyone can go up. You step out of the rig and it's just like sink to your knees, and you're like, okay, well, I guess it didn't refreeze because of cloud cover or something. And you go up there another day, I'll be like, oh, it was 38. You know, no one can work. It's going to be all just falling apart. And you go up there, surficial refreeze. Everything's locked up and fine. And it's just, yeah, really complicated forecasting to try to dial in, but really interesting, right? Because we normally don't get to deal with these kind of parameters or have to think about them as forecasters. And maybe that's going to be a thing that we might have to think about more.
So when the rain is not having much impact on the snowpack, is that a snowpack that's already been through some melt freeze?
Yeah.
Okay.
If it was just raining on like a dry or a drier snow, right? There's this whole spectrum of snow. I would think that that would be significant, like causing some instability. But
I was just curious, up there, I mean, certainly in this area, I'm not sure about the Tetons, but one of the things we've noticed this year is that we haven't had the warm-ups, so we're looking at now an April warm-up with some pretty powerful sun. I was just curious what the situation is up in Glacier this year. Is it similar, where you're dealing with up till April 5th a really winter-like snowpack, and now we're going to heat it up and you're going to be forecasting up there?
I'm actually more concerned about the Tetons for that. I mean, I have 2 days of turnover before Glacier, and I've kind of like looked at that snowpack a little bit, and it trends a little more maritime anyways. So I feel like it's kind of used to those sort of swings, but it's stayed pretty cold up there. And in the Tetons, we definitely have that. Like, I already have started writing into my forecast, like next week it's going to be warm and sunny, and like, you know, people are commonly up at 13,000 feet in the Tetons every week recreating, which is like a interesting demographic to forecast for. And you're like, do not when it is warm, like it's gonna happen fast. Like there's gonna be a significant shed cycle there, and pretty similar to here, I would bet. And I think it's scarier to me than Glacier, because you're gonna have triggers everywhere. But yeah.
Gabby, do you all have lysimeters or soil moisture sensors or anything currently at Glacier monitoring the movement of the waterfront?
Yeah, the garden wall has a lysimeter, so you can tell. But that's the only one, so.
Good.
Yeah.
Awesome. Thank you so much.
Yeah.